Mic test, mic test. Hello?
Hello? Hello?
Pa-check ako sa YouTube.
Sige. Wait lang. I shall check. Okay. Naka-live na.
Naka-live na ba, As?
Ay, oo nga. Naka-live na.
Ayan. Try... Try i-share screen yung... Ano tawag dito? Yung sinad ni Ma'am Eme kanina. Ma'am. Yung while waiting.
Pwede ba yung sounds?
Hindi ata.
Okay. Wait. Ngayon ba?
Yan, meron. Check ako sa YouTube. Yan, meron. Ang ganda naman ng gawa ni Eme. Check ako sa YouTube. Yan, meron. Yes. Yes, Ate LK, may sounds na po.
Good morning. Morning. Wala pa, Shirley?
Morning po.
Wala pa si Shirley?
Wala pa naman, ma'am.
Ako nag-confirm siya. Ngayong umaga daw siya.
Yes po.
Eh,
Good morning, Sir Lee. Sir, gusto niyo
Oo.
po mag-test
Ay,
before
ako na ba?
magpapasok? Opo, sir. This sir, mag-test muna tayo before magpapasok ng participants.
Sino yung magre-present?
Kayo, sir, kayo muna, sir. Sir, kayo today.
The whole day?
Yes, sir.
Okay. Ma'am Ash, hindi, kala ko hati tayo sa ngayong morning.
Yun nga, sir. Pero natapos ko kasi kahapon na yung lecture. So, okay lang, sir. Pwede na kayong mag-start. Tapos kung kung hindi nyo nakukunin yung last na lecture, okay lang yun. Parang na lang. It's either early, na lang, early end. Kung hindi nyo siya makukuha yung buong, yung last na session.
Okay. Elkie, pwede na ako mag-share?
Oh, sir, muna. Kahit test muna, sir. Sige po.
Yes. Sige.
Okay. Okay naman, sir.
Kita naman. Okay.
Yes, sir.
Sige,
sir.
stop
Papasok
share
na
ko
po
muna.
tayo ng Aba. Tapos
Okay.
mag-admit na po ng participants.
Okay.
Sige, sir. Thank you. Hello, good morning everyone. So let's just wait for a few minutes and we will start at 9:10 a.m. Thank you. Hello? Can you hear me, guys?
Yes, dear.
Yes, ma'am.
Hi. Okay po. Thank you. So, thank you again for joining us today here in Track D of the 26th Summer Institute in the Natural Sciences and Mathematics. So, before we start, I'm just going to go through some reminders. Okay, wait. So, medyo mahina daw lang po. Lang po ah. Hello?
Better
Better
po.
po ba? Better. Okay. Thank you. So I'll just go through some reminders now for all attendees. So please observe the following etiquettes. So please turn off your microphone and webcam during the talk, and please post all your questions in the chat box. So this will be asked by the moderators. And please let's also we can utilize the react buttons so we can communicate with the speaker. And then towards the end of the last presenter scheduled for today, we will send the link for the evaluation form, and certificates will be awarded to attendees who attended at least 75% of the talks in this workshop. Okay, so I guess we can start. So I'll be introducing our speaker or lecturer for today. So he finished his bachelor's degree in computer science at the University of the Philippines, Baguio in 2011. He pursued further studies at UP Diliman, where he acquired his master's degree in computer science. He is currently an assistant professor here at UP Baguio under the Department of Mathematics and Computer Science. So to discuss further on Java programming, let us all welcome Professor Lee Haveliana.
Thank you very much, Elkie, for that introduction. Please bear with me for a few minutes while I set up my presentation.
Ay, sa kuan ha? Murag muong. Slide. Para ko lang save kalibang na. Save sa lang. Doon lang ka slide lang.
Okay. So good morning, everyone. So for today, I'll be lecturing on a bit more advanced topic for Java. Today we'll be taking a look at advanced data structures. This will become important, especially later on when you start creating bigger, larger, more complex programs, like for example, your apps or simple programs to help you with your work. So this will be the outline of my work. Please bear with me for a few minutes. So this will be the outline for my talk for the day. So we'll have an introduction to what are advanced data structures. Then we'll take a look at some basic ADTs or abstract data types. Okay. Then we'll also have a coding demo where I'll be demonstrating, and you can also follow along on how to implement these advanced data structures in Java. Okay. So for the introduction, okay, so take a look at data structures and abstract data types. So a data structure is a representation of data and the operations allowed on that data. So in the lecture yesterday by Ma'am Ash, you were using variables that hold data. Now, medyo advanced na, you have data that has, or a data structure that has the data or values that you store in. But now you have operations that manipulate the data that you store in it. So in object-oriented programming, data and operations that manipulate the data are grouped in classes. So we might be seeing some of these especially in the coding demo. Okay? And these are called abstract data types or ADTs, or also data structures, or you can also call them collections. They store data and allow various operations on the data to access and change the data. So the question here is, why use abstract data types? So you have to specify the operations of the data structure and leave implementation details for later. Okay? And there are many different ADTs. More importantly, picking the right one for the job is an important step in the design. So I borrowed a quote from a famous computer scientist. Get your data structures correct first, and the rest of the program will write itself. And I noticed on a personal level, I tend to think of the data structures, or how will I store the data and manipulate the data, even before I start creating the program that I want to make. And fortunately, high-level languages like Java, C++, Python, if I'm not mistaken, and other high-level languages and modern data languages, they often provide built-in ADTs for you to use already. But there are some older programming languages, like for example in C, that don't have these built-in or pre-built ADTs, so you have to build them from scratch. So that's why in these newer ones, when the program designers or programming language designers thought of this, they thought maybe we can pre-build these ADTs so that you don't have to keep on making them whenever you make a program. So some basic operations of ADTs. Every ADT should provide a way to, of course, add an item or an element to the ADT, remove an item from there, find, retrieve, or access an item. And yeah, these are sort of the three basic operations that an ADT has, so that these provide a way of manipulating the data that you have or that you store in your abstract data types. And you can have more possibilities, like for example, check if your ADT or collection is empty, or you can empty the collection or remove all the items, or maybe get a subset of the collection, or find out how many items are in that collection, etc. So, and there are many different ways to implement these operations, each with associated costs and benefits. And yeah, sometimes we have to think about how will or what kind of ADT we'll be using, because there are some pros and cons when choosing one ADT over the other. So when you implement your ADT, so when implementing an ADT, the operation behaviors must be specified. So fortunately, with Java, with the pre-built ADTs, um, it's found in the Java API. So all you need is to look up the methods that you want to use, or look at the methods that are available, and you can choose which one you can use there. And the first decision is what to use as the internal storage container for the concrete data type. So the internal storage container is used to hold the items in the collection. So you can think of this as your data holder, or this is where you're going to store your data. So often an implementation of an ADT. Initially, there are not many choices for storage containers. You can have arrays, or you can choose pointers. And here we'll go to some basic ADTs. So the first one is a set. So, and these are similar to your sets in math. So a set is a collection of members or elements. Each member is a set of primitive element called an atom, and all members of a set are unique. And here are some basic operations that we usually do on sets. You have the union of sets, the intersection, difference, and you can also have to check if an element is a member of the set or not. So to explain it a bit further, so union, medyo familiar ito sa akin, so sa atin. So the result of this operation is the set consisting of all elements that belong to either the set A or to set B. So it's the union operator is given by what looks like a capital U. So A union B is equal to X, where X is an element of A or X is an element of B. And here's an example. So pansin niyo, pinagsama lang yung dalawang sets na to. Okay. And the intersection, so the result is the set of all elements that belong to both A and B. So here, kinukuha mo yung yung common between the two sets. So yung symbol for that is yung inverted U. So ito, A intersection B. So X is an element of A and an element of B. So here's another example. So yan, pansin nyo, yung common lang dito ay yung B, element na B dito. So ito yung intersection of the two sets. And the difference, so the result of A minus B is the set of all elements that belong to A but not to B. So just like sa algebra, important dito yung order of the sets. So kung A minus B is the set of all elements that belong to A but not to B, kung baliktarin mo, B minus A, mag-iiba din yung result niya. So, ito yung formal definition ng difference. And here is an example. So, yung A minus B, tinanggal lang kung ano yung in common sila and naiwan na lang since B is what's found here in A. So, tinanggal mo yan. But all the other letters are not found here. So, yan na lang naiwan. A, C, E. And then you can have a custom operation on the set, maybe like this one, member. So returns a Boolean value and returns true if X is an element of A and false if X is not an element of A. So another example, so ito, A is equal to this set. So if you're checking if C is a member of the set A, magre-return siya ng true. And if you try to check kung member siya or if the letter D is part of the set, and since wala siya dyan, magre-return ng false yung operation na to. So, we come to arrays, and those of you who have some background in programming, medyo familiar na ito sa inyo, arrays. So, medyo just a background lang and medyo formalization of yung definition ng array. So an array is a structure consisting of fixed number of components, all of the same type. And you have the characteristics of an array. Of course, you have a name. Then yung component type, which is usually the data type of the elements or the items in the array. And of course, you have your index. Then you have some operations. You can search. So search for an item X in the array, or you can retrieve, or get an item at the index specified by I in the array. And of course, it can be one-dimensional or multi-dimensional. And here's a visual example of a 1B array. Medyo familiar sa atin for those who have background in programming. Medyo familiar na ito sa atin. So you have index, so starting from 0, kasi sa Java, indexing always starts at 0 for Java. So 0, 1, 2, 3, 4, 5, 6. And then these are the items stored in the array. Okay. Then you can also have a 2D array. So example dito. So note lang, yung subscripts dito indicate the index numbers for the items. So yung 5 dito ay 0, 0. Yung 3 naman ay 0, 1, meaning first row, second column. Same with 9. Yeah. So, yan yung 2D array nyo. So, of course, your arrays are not limited to only 2 dimension, pwedeng 3 dimension, 4 dimensions, 5, 6, pwedeng any number of dimensions yan. So, medyo mahirap i-visualize, lalo na yung mga 4 dimensions up. But yeah, in computer science, lalo na sa machine learning or artificial intelligence, they make use of high dimensional arrays. Usually, you can run into the hundreds or maybe thousands. Ganun kalaki usually yung mga arrays ginagamit for machine learning and artificial intelligence. But I think if you're teaching sa high school, maybe you can limit it lang muna to 2D arrays, 3D, maybe you can go 4. And we come now to yung lists. So definition, a list is a collection of objects of a single type. One of the most important ADTs, since so many operations in computer science involve lists. So for your data, it's a set of elements from A1 all the way to AN. And you can have these possible operations. So you have your find. So find the first element on the list having the value of X. Or you can have you find kth. So find the element in the position or index I. Then you have insert X at I. So insert element with the value of X after position I on the list. Or you can have remove first element having the value of X from the list. And of course, if you want to know kung anong laman ng list mo, you can also have an operation na ipiprint lang niya yung list. So, when we try to implement yung lists, there's an issue sa implementation. So you have to choose the data structure that implements your ADT in the best way. So for a list, you can have an array, or you can have a linked list, or kumbaga sa C programming, you have to make use of pointers. So here, you need to weigh the advantages and disadvantages of each, and also take into consideration the program that you're trying to create. So I think it's best if I show you this table where it shows a comparison of using an array or linked lists or pointers when implementing yung lists. So yung array, fixed storage size siya and must be contiguous or kailangan, usually in Java, in C, and almost any programming language, when you create an array, it will try to reserve the biggest block of memory na magkasama in your computer, on your computer or device. To try to reserve that whole block of memory, and para sa kanya lang yun. But sa linked list, it can grow dynamically and does not need contiguous storage. So pwedeng, if it cannot reserve the whole block of memory, pwedeng part dito, it will take several parts to fill up or to fulfill the requirements that you need. Now, medyo side story ito. May na-experience ako, I had a undergraduate student. He was working on his special problem, which dito sa UP Baguio is like the undergrad thesis ng ComSci. So he was working on his special problem. Tapos he approached me, sabi niya, "Sir, nagkakaproblema ako sa program ko." Sabi niya out of memory daw, hindi daw niya ma-allocate yung memory. Tapos tinanong ko yung specs. So, ano yung specs ng computer mo? Tapos sabi niya, medyo high-end nga eh. I-Core i7, tapos naka-SSD pa siya, tapos yung memory niya, 32 gigabytes of memory. So, nagtaka kami, bakit ayaw niya mag-allocate ng memory? And then, I was looking over his code, napansin ko, gumagamit siya ng array. And yung problem na gusto niyang isolve, medyo malaki yung array na kailangan niya para isolve yung problem na yun. Sabi ko, can you try changing yung array into a linked list? Kasi baka yung problem doon, hindi niya ma-reserve yung kailangan niyang memory size. So, trinay niya, binago niya, ginawa niyang linked list yung array niya. Nung pinalitan na niya yun, gumana na yung program. So, yeah, those are some considerations when you choose between array and linked list or pointers. But with the arrays, you have faster random access if location or your index is known. But sa linked list, medyo mabagal kasi you must search to the list to access an item. Sa array naman, need to shift items if inserting somewhere in the middle. Sa linked list naman, can easily insert an item anywhere in the list. And sa array, removing an item may require shifting of remaining elements, while sa linked list, when you remove an item, it involves searching, pero pag remove niyan is just as easy as inserting an item anywhere on the list. Now, baka might be thinking, so which one's better, array siya or linked list? Well, there's no clear answer there. It will really depend on what you're trying to solve na problem or what program you're trying to create. You just have to keep in mind na kailangan you weigh the pros and cons of each one. So, array ba mas okay sa program nyo or linked list? Okay? And then, the next is yung stack. So, the definition, so a list in which all insertions and deletions are only at one end of the list, which is called the top. So, elements follow the order last in, first out, or yung tinatawag natin na LIFO. And insertion and deletion have special names for the stack, yung push and yung pop. So, same din siya sa list. So, it's a set of elements. And then your basic operations here are push and pop. So, push, insert the element with the value X at the top of the stack. And then pop, remove the top element of the stack. And then, when you implement, so you have to choose whether an array or linked list. So kapag array, pwede naman, pero can be tricky because it involves shifting the elements, lalo na when you put an item, tapos may laman pala yung stack nyo, or when you try to remove an item from your stack. Okay. And sa queue, so queue, medyo familiar ito sa atin. So queue is another word for a line, follows the first in, first out order. So parehas din sa pila or sa line. Dapat, lalo na sa grocery, tama, kung magpipila kayo, kung ikaw na una dun, dapat ikaw una ma-serve. Hindi naman pwedeng kung ikaw na una dun, tapos yung iaano dun ay yung nasa likod mo. Okay? So, same din siya sa list. It's a set of elements. And then, you have your basic operations na in queue, that should be the queue. I will change that. Sorry about that. So in queue, insert element with value X at the end of the queue or the line. And your DQ is to remove the first element from the queue or the line. And sa implementation, yun pa rin. Kapag array, pwede naman, pero can be tricky kasi it still involves shifting yung elements. Then you have your linked list or pointers. And now, we come to yung trees. So a tree is a finite, non-empty set of elements or nodes. One of these nodes is called the root. So the remaining nodes, if any, are partitioned into trees, which are called the subtrees of T. So trees are useful for hierarchical order data. So I think we're familiar with this. So example dito, employees of a corporation. So you have president, vice president, managers, and so on. And parehas din sa Java classes. So the object class is the top of the hierarchy. Then you have subclasses of the object are next, and so on and so forth. So baka medyo mahirap lang i-visualize ito. So here's a visual example of a tree. Hiniram ko yung hierarchy ng Java or Java classes. So here, you have the object being the highest class in Java. And then below that, you have other classes. So example dito, number, throwable, output stream. And yeah, you have other subtrees or subnodes dito. And we're familiar with this type of graph or representation. So kung sa corporation ito, so you have the president, vice president for marketing maybe, vice president for production, vice president for I'm not sure, maybe another vice president, and you have managers or Luzon managers, Cebu managers, ganun, Mindanao managers, Visayas, and then here you have under, let's say, dito sa Visayas or sa Luzon, pwedeng you have NCR managers, then meron dito sa Baguio. Okay. Now, here are some concepts also sa trees. So you have subtrees. So here, nodes of the same color belong to the same subtree. So dito, looking here, yung blue dito is a subtree dito sa object na to. Same with yung throwable. So ito, subtree siya. And ito, subtree din siya. So you have 3 subtrees. And of course, kapag dito sa number, may subtree ka din dito na integer. Or dito sa throwable, yung subtree niya ay exception and runtime exception, etc. Okay? So your subtrees can have subtrees and your subtrees can have subtrees. But of course, paano naman yung dito sa dulo? Well, these are what we call yung leaves. So ito yung green nodes dito ay yung leaves of the tree. So meaning yung pinakadulo na ng tree. Okay? Then you also have what they call yung relationship of nodes, and familiar tayo with the family terms like parents, children, siblings, ancestors, and descendants. So they also are, you can also use them when referring to yung nodes of a tree. Okay? So for example, dito, si object is the parent of throwable, and si number, throwable, and outstream are the children of object. Tapos grandchildren naman si integer, double, exception, and file output stream ni object. Yeah. Then, for example dito, yung runtime exception, ancestors niya ay exception, throwable, and object. Okay. Then yung siblings dito, of course, yung dito sa same level. So, integer, double, exception, and file output stream. These are all siblings. Okay. Yeah. Then, you also have yung levels and height of a tree. So, note, some references start the root node at either 0 or 1. In this picture, we have, or we're starting at level 1. So, the height of the tree is the depth or the highest level of the tree. So, ito yung level 1. Ito yung next level, na level 2, the level 3, tas level 4. So, yung highest level ng tree na to ay 4. Of course, kung wala ito, yung highest level mo is 3, and so on and so forth. Then, we also come to yung definition or yung concept ng node degree and tree degree. So the node degree is the number of children a node has. So dito, si object has 3 children. So yung node degree niya ay 3. Tapos yung number dito has 2 children. So yung node degree niya ay 2. Pero si integer tsaka double, wala silang children. So yung degree niya ay 0. And the tree degree refers to the whole degree is the maximum number or the maximum node degree or maximum number of children a node can have. Well, in this case, tatlo, we can assume na tatlo yung highest or maximum number of children that a node can have. So yung 3 degree dito ay 3. But of course, this will depend on how you want to implement your tree. Okay. Any questions so far before we get into yung coding demo? Okay, so let's proceed to yung coding demo, part 1. Okay, so first let's take a look at yung sets in Java. So recall a set is a collection of members or elements of a set. So to use the built-in package or built-in set of Java, we need to import 2 packages, yung java.util.set and java.util-hash set. So these are the 2 codes, and you have to declare it at the very top of your code. Don't worry, I'll be demonstrating this in a few minutes. Medyo background lang muna tayo. Okay, so this is how you declare a set. So you use the reserved word set followed by yung less than sign. Then you have to define a collection type, and note your collection type must be an object data type. So ano yung object data type? These are the data types in Java that are able to store data or values, and they also have operations that you can use to manipulate the data. So parang abstract data types din sila. But here sa Java, they're called object data types. One of these examples is yung integer. So take note, this integer here is sort of similar to the int data type which you were using yesterday. Pero yung int is a primitive data type na kaya lang niya i-store yung value ng integer or yung int. Pero yung integer na to, it can also store a value, pero it does have methods or operations that you can use to manipulate the data. Okay. And then of course, don't forget the name of your set, and then it's equal to, and then you have to instantiate the object or the class, sorry. So new, and then take note, hash set and collection type. Now, pansin nyo, magkaiba to. That's because yung set is just an interface, or you can think of it like an outline or a blueprint. Pero yung parang base niya ay yung hash set talaga. Okay? So, as an example, ito. So, we're declaring a set of integers. So, set, and then yung object data type ay integer, and new hash set. Yeah. Okay. Then, for yung set operations, to add an element, you just use the method na add, and then whatever element you want to add to the set. And then if you want to remove an element from a set, so just use the method na remove, followed by what element you want to remove from the set. Okay. So for the coding demo, we'll be declaring a set, then we'll add an element to a set, remove an element from a set, and then we'll do yung set intersection, set union, and set difference. Okay. Please give me about 2 minutes to set up. for the coding demo? Can everyone see my Eclipse?
Yes, sir.
Okay. Malinaw naman, hindi masyadong maliit yung font.
Yes, sir.
Okay. So first off, so this is our set demo, and I'll just be using one class dito with yung main na method dyan. Okay. So we'll declare a set. So we'll have set. So recall, ganyan. So use the reserved word set followed by whatever object data type you want to use. So here I'll be using yung integer, and we'll have set a equal to new, then hash set hash set. Ayan. Okay. And then, pansin nyo, nag-error dito si Eclipse or whatever IDE you're using. The nice part of this Eclipse, you can easily fix this by putting your mouse over the error, and then it will suggest some fixes. So usually yung pinakauna is usually the best option or yung tamang sagot. So dito, import set java.util. So automatic niya ini-import yung package na yun. So pansin niyo, it imported the two packages that we need. It imported the two packages that we need to use yung set. Okay. Now, I'll do something a bit different dito. Kasi, like in your programming or coding exercises yesterday, pwede kayong mag-declare ng variable tapos pwede niyong initialize kaagad. And pwede rin dito sa set or almost any collection, you can also initialize. I forgot to include yung object data type dito. And that's usually by inserting what data you need here. Dito sa parentheses na to. What data you want to initialize your collection with. So, dito I want to initialize some values muna. Pero medyo a bit tricky ito. Sort of. May kailangan lang dagdagan na command or class. So here we'll be making use of the Java class arrays, and then we'll use the method na asList to convert this list na 1, 2, 3, 4 into a list that can initialize our set. Yeah. So far no errors sa Eclipse, so meaning okay pa. So I'll create another set. So, copy ko lang to. Of course, you can't have two sets with the same set name. So I'll make this set B. And then I'll initialize different values naman dito. So 2, 4, 6, 8. Okay. And now, I want to check kung tama naman yung pag-initialize ko or pag-declare ko ng set. So one way to do that is to print out the set, but in this case, there's no method sa Java or built-in method ng set sa Java that will print it out. So I'll make my own method na lang muna. na print set. So as input parameter, yung set lang, set of integers na ipapass lang niya to the method. Okay? Now, sige, I will type in muna the code. Okay? So this is the code that I'll be using for my print set method. So anong ginagawa ito? So if you notice here, I have a for loop, but this for loop is different from what you saw, if I recall the lecture from yesterday, from what you saw yesterday. Now this is a for each loop. This one is found in Java. I'm not sure if it's also found in other programming languages, but here's a Java. They have what is called a for each loop. It's similar to your for loop, except siya nang bahala to go through the whole collection or array or linked list, or in this case set. Siya nang bahala to go through all of that and to print out, or siya nang bahala. So no matter what the size of your array, your linked list, siya nang bahala, but it will go through each one, through each element, one by one. Now, I haven't seen any documentation about this for each loop. Pero parang it starts from the very first element and then goes all the way to the end of the collection. But I cannot definitely say na ganun yung pag-print niya. All I'm sure is ipe-print, or it will go through all the elements of your collection. Now, in what order, I cannot really say. Okay? But for this one, hindi masyadong importante yung order kasi we just want to see the yung laman ng set. Okay? And then to help you guys follow along, I will make a paste bin link for the code. Can you try if you're able to access the paste bin link that I gave?
Yes, sir. Accessible po siya.
Accessible. Okay. So you can go ahead and put that in your Eclipse or any IDE that you're using, and it shouldn't matter talaga. Okay. So I'll continue with my demo. So I just want to print. Just a side note pala, yung dito, system.out.println, pang formatting lang, just to make the output look nice. So same here. Do print. I'll put a label lang, or mag-output lang ako ng label para lang I know which set it's printing. Okay, so we'll start with yung set A. And let's print. Let's run, sorry. And yeah. So parang tama naman. Na-print out niya yung laman ng set natin, which is 1, 2, 3, 4. So copy-paste ko lang to. But this time, I'll try naman yung set B. And when I run and check the console, ayan. So, parang tama naman yung pag-declare natin ng set. Okay? Now, let's try adding an element to a set. So let's try yung set A. So automatic sa Eclipse, and I think for almost any IDE, may ganito, parang helper or predictor. It's trying to predict what you want. Okay, so we'll use the method na add. Then let's try adding the value 5 to yung set A. Okay. So if we run, ayan. So, pansin niyo dito sa console, nadagdagan yung element na 5 to the list. So, maybe you want, parang if you're not convinced, pwede niyong copy-paste. Say, let's add 7. Ayan. So, nadadagdagan naman niya yung it's adding to our set naman. Okay. Now, let's try removing an element from a set. So, this time we're using set B. So let's remove. Now, I want to remove, let's say, the value na 6. Okay. And of course, we leave this one here to print out para to check kung tama naman yung pag-remove niya ng element. So, if we run, okay, so, natanggal niya yung 6. Well, hindi ako masyadong convinced. So, let's try doing 2. So, natatanggal naman niya yung elements that we want. Okay? Questions so far? Questions? Okay. So, okay pa? Now, let's let me just switch back for a while. Okay. Okay. So we declared a set, then we added an element to a set, sorry. Then we removed an element from a set. Now let's try to do a set intersection. Okay. I will just comment these out muna. So yung mga comments sa Java, i-ignore ng Java compiler and it won't execute them. So I'll just remove these add muna. Remove and add. So that we're left with the original sets na 1, 2, 3, 4 and 2, 4, 6, 8. Now, to do an intersection of the set, since most of the set operations here, they manipulate the data, I will declare another set na lang. Kasi ayokong galawin yung nasa loob ng set A or set B. Then, we have intersect set. Okay. And then, now, I want to get muna yung set na A and I want to put it into yung intersect set. Now, I could do that medyo mano-mano, parang yung print set dito, tapos i-add na lang niya mano-mano, or I can also initialize the declared set by just putting the set dito. Okay? So, just to check kung tama naman nakuha niya yung intersect set, yung values ng set A, I will print it out muna. Ayan. So, lumalabas na kinuha niya yung values in set A tapos linagay niya in our new set na intersect set. Okay? So, how do you do an intersection? So, to do that, we'll make use of the retain all method. So, yung tip dito ni Eclipse, so retains only the elements in this set that are contained in the specified collection. In other words, removes from this set all of its elements that are not contained in the specified collection. So if the specified collection is also a set, then the operation effectively modifies this set so that its value is the intersection. Ayan. That's a documentation on Java. So this is how you do the intersect. So we want to see the intersection between set A and set B. So we use yung retain all, and then we choose yung set B kasi yung intersect set natin already contains the value of yung set A natin. Yan. And then I'll still retain my print out dito, yung print set. So let's see. Let's run. And tama naman yung pagkuha niya ng intersection. So if gagawin natin mano-mano ito, so yung intersect ng set A tsaka B ay dapat 2 and 4 kasi common sa dalawang set yung 2 and 4, which is nakuha naman ng program natin. Okay? So that's how you do an intersection, or how you do the intersect operation sa Java. Okay? Now, let's go to yung union of two sets. So I'll declare another set, but this time gawin kong union set, and same pa rin, kukunin niya muna yung values ng set A. Then the union, for a union set, union, we'll use the add all method. So, yung gagawin ng add all, idadagdag lang niya yung elements ng set B dun sa union, or kung anong laman na ng union set, which is yung set A natin. So, kunin niya yung elements ng set B, dadagdag niya sa union set, and yun ang magiging union natin of the two sets. And of course, ipiprint out ko to just to check. Copy ko lang to. Okay. And if we run the program, so nakuha ba niya? Okay. Nakuha naman niya. And recall, your set, all the members there are unique. So kahit na may 2 and 4 in set A and set B, ika-count lang niya as one element siya. So hindi na niya idadagdag yung 2 tsaka 4 into set A kasi meron na yung 2 and 4 doon sa set na yun. Okay? Any questions, clarification so far? Okay. So kung walang tanong, our next one will be to get the difference, the set difference. Okay. So I will make another set din. Okay. And rename ko lang. Okay. Now, to get the difference of yung set, we'll use the method na remove all. So, reading the documentations, yan, yung second line. If the specified collection is also a set, this operation effectively modifies this set so that the value is the asymmetric difference of the two sets. Okay? So, ito yung gusto natin. Yung difference ng two sets. So, since the different set already has the set A in it, so we'll try to get the difference niya kay B. Yan. Then, we'll print out. Copy ko lang to. Ayan. Okay. So, if we run this, dapat tatanggalin niya yung hindi or yung nasa set B pero nasa set A din. And may iwan dapat yung nasa set A lang. So difference, let me adjust lang. Tama? So, 1, 3, 1 and 3. Kasi yung 2 and 4, common sila. So, dapat tanggalin niya. Yung 6 and 8, wala naman sa set A. So, okay lang. So, yung naiwan na lang ay 1 and 3. There. So, these are just some of the basic set operations that you can use and how you can declare a set sa Java. Okay? Any questions? And I'll also send the code. Give me a few minutes. I'll send it on Pastebin para to give you a sample and also for you to try out in your free time. And you can also use this for your classes. There's the link to the code, and please try the code and tell me if you're able to access it.
Yes po, sir. Na-access po.
Okay. Okay, good. Any questions about yung pag-implement ng stacks ng sets sa Java? Okay. If there are no more questions or there are no questions, I think I will end muna this session dito. Para makapag-early lunch tayo. Tama, Elkie, we're supposed to be until 11:30, tama?
Yes, sir. Si Cindy po. Nawalan
Cindy,
sila
sorry.
ng kuryente.
Okay, sorry. Cindy, yeah. So, okay lang kung mag-end tayo ng medyo maaga para medyo mag-early lunch tayo.
Okay, sir.
Unless there are questions from the audience. Okay. So, kung walang tanong, see you guys later in the afternoon session.
Sir, what time do you prefer?
Let's stick with the schedule, 1 o'clock.
Okay, sir.
Tama ba? Tama ba, Cindy? Yung
Yes po.
1 o'clock. Sige. Yeah, 1 o'clock na lang. Let's stick with the schedule. Okay?
Okay,
Thank you.
sir. Thank you.
And enjoy your lunch, everyone.
You too, sir.
Thank you.
Mm. Okay. I'll end this video for now, and we'll be back by 1 o'clock. Thank you.
Hi, Celeste. Hello?
Hello, hello. Wala pa rin.
Ang alin?
Sounds po. Dun sa share screen ko po.
Sige, ay sandali. Ang gawin mo, i-click mo yung share screen, di ba? Click mo yung share screen, tas may makikita kang share sound.
Ito na.
Okay. Okay. Sir Lee, can you hear me?
Yes, Cindy, I can hear.
Nawala na ata sila ulit.
Wala.
Oo, ako na lang muna, sir. I-admit ko lang po lahat. Tapos mag-announcement lang po siguro ako. Yung
Sige.
regarding sa MSP at saka yung nanalo kahapon. Kung okay lang po.
Sige lang. Basta prompt mo lang ako na kung kailan ako mag-start.
Okay, thank you, sir.
Okay.
Okay, good afternoon. It looks like we're still waiting for some of your fellow participants to join us. So while we're waiting, I'd like to announce we have an MSP registration for which is the Mathematical Society of the Philippines. It's a membership for all who are in the field of mathematics. If you are interested to join, you can hang on. Oh, wait, something's wrong. Okay. Can you see my screen? Or
Yes, ma'am.
okay. Okay, it's the MSP. It's the MSP. The barcode for the registration is attached in is in your screen. So if you can take a picture of that, and you can register if you'd like. One of the board members of the MSP is our chairperson, Dr. Isabel Adawe. So rest assured that it is not a scam. Okay, I am also a member of the Mathematical Society of the Philippines, and just to give you a few of the benefits of being a member, bear with me. Let me just open my let me just open one file. Okay, bear with me. Let's see. SINSM. Okay. All right. It is the Philippines, okay, Mathematical Society of the Philippines is the Philippines' premier professional organization dedicated to the promotion of mathematics research and education in the country. It is governed by the National Board of Directors elected by the general membership, and it has regional chapters throughout the country. Now, in the Northern Luzon, we have the CAR, the Regions 1, 2, and 3 chapter. If you are a member, then you become automatically a member also of the National MSP, and likewise, the Southeast Asian Mathematical Society, or the SIAMS, all right? For those who are interested to apply or renew their membership, you may visit the membership form through through the following link. Okay, you can also you can screenshot the barcode in the screen right now, and the membership fee and the deposit accounts are indicated there. Once you have paid your membership fee, please secure a copy of your receipt and upload it as a proof of your payment. Okay, we will then if you have further questions, please do not hesitate to send us a message, and we will get back to you with your queries. All right. And one more announcement to those who won yesterday. We will be considering the top three. Okay. What's their name? Ang nakalagay sa screens nila, yung screen names na ginamit nila is what? Andali. Wala yung eyeglass ko. You have Buboy, you have Nial, and you have yung top one, hindi ko makita.
John Ray, ma'am.
Oo, John Ray. Okay. Please give us a private message so that we can, please give us your email address or contact number so that we can contact you, and Ma'am Ash will be deciding on a reward for you. So yung top three, John Ray, is it? John Ray, Buboy, and Nian, please give us a private message so that we can coordinate with you on your prize for what do you call this? Winning yesterday's game and participating during the discussion. All right. So those are my announcements. So let's. I think we have how many participants? Only 15 participants. I just like to remind also everyone that you will only get your certificate of participation if you completed at least 75% of the SINSM program. So I encourage everyone to please to join the whole session so that you can have your complete certificate. All right. So I'll give it to Sir Lee so that he can continue with his lectures on Java. Okay. Sir Lee, thank you.
Thank you, Ma'am Cindy. So good afternoon, everyone. I hope everyone had a good lunch. So we will continue with our programming demos for the advanced data structures in Java. I will share my slides again. Can everyone see my slides?
Yes, sir.
Okay. Just give me a few moments. I'm setting up here on my end. Okay. So just a recap. So a while ago in the first session, we were coding sets in Java. So we were able to declare a set. We added elements to a set. We also removed elements from a set. We did the set intersection, set unions, and the set difference. And next, so for our next abstract data type in Java, we'll be taking a look at linked lists. So linked lists, just a refresher, are linear collections of self-referential class objects, or they're called nodes. So just like with the sets, there is a built-in package for in Java. So all you have to do is just import the java.util.linklist package, and just like with the sets, you have to declare it at the top of your code. And same with the declaration, it's the same with the sets. Of course, just change the class to linked list. Your collection type still must be an object data type. It cannot be the primitive data type. Then you have to provide a name. Then to instantiate, use the new reserved word followed by linked list, and then of course the collection type, and close and open parentheses. And here is an example, and don't worry, I'll be providing the real example or the coding demo later. And here are some linked list operations. You can add an element to your linked list. Now, if you notice here, the first method listed here, you have add. It adds an element to the end of the list, then add first, and then add last. Actually, add last and the add method are similar. They do the same thing. Add an element to the end of the linked list. Now, why is there an add and then add last? Well, it was those who designed the package, which were the programmers at Java. I don't know why they included it, but maybe if you want um, maybe a specific method, you can use add or add last. But just take note, since Java is an object-oriented programming language, this add method might change in the future. We cannot really say. That depends on the developers of Java. So maybe they might change this to add an element anywhere on the list, or anything, or maybe at the end, or maybe middle, or maybe beginning. We do not know. So we're not sure if this will change in the future or if it will stay the same. Now with the add last, at least this is sort of set, or you're sure that from the method name itself, you're adding an element to the end of the list. But for now, the add method and the add last method are basically the same, or they do the same thing. They add the element to the end of the list. You can also get the size of a list. You can remove elements from a list. Now, if you also notice here, the remove and remove first methods do the same thing. Now, it's just like with the add and the add last. I don't know why they have two methods that do the same thing. Well, that was up to the developers of Java, right? Okay. And maybe some clues also is later on when we look at another or two other abstract data types, we might see the answer there. Okay. And then now take note, when you remove an element, you're really taking it out of the list. But you can also just retrieve the element. So for example, here, the first one, the peek method retrieves but does not remove the first element. So if you just want to look at what the element is or what the items are, maybe you can use peek, or you can use peek first. And excuse me, just like with the add last, remove, and remove first, so you have a peek and then peek first that do the same thing. Then you can also peek last, which you take a look at the last or the end of the list. Or you can also use the get method here, where you can specify the index, so retrieves the element at the position specified by your index. And take note, for Java, the indexing, even with linked lists, it starts at 0. So for our coding demo, we'll declare a linked list, then we'll add an element to a linked list, remove an element from a linked list, we'll peek at an element or we'll retrieve an element from a linked list, and then we can also sort a linked list. So please give me a few moments for me to set up my Eclipse. Okay. Can everyone see my Eclipse?
Yes,
Yes, sir.
Okay, thank you. Okay, so I went ahead and created a new Java project in Eclipse, and I just made a single class linked list demo, and I just need one class to do this demo. Okay, so first let's start by declaring our linked list. And of course, the collection type must be an object data type. And also, don't forget the object data type there when you instantiate it with the reserved word new. Okay. There. Now that we've declared our linked list, we'll populate it using the add method. And for this, I'll use it with a for loop. So I'll just fill it with numbers from 1 all the way to 10. And I'll be using the regular for loop, not the for each for loop. Okay, so technically we're adding the values 1 to 10 into the linked list, but of course I want to see and check if I'm really adding those values to the linked list. So for that, well, just like with the sets, there's no built-in method to print out the linked list, so I'll make my own method. So for its parameter, input parameter, sorry, excuse me, I'll just be passing in our linked list of type integer. And then just to make it look good, I'll add some other output information. And then for this, excuse me, I will be using the traditional for loop where I'll be going from 0 all the way to, since you can get the list size, so all the way to the end of the list, and I'll use the dot size method. Okay. And then here, I'll just simply print out the value. Sorry. And then for this, since I'll be retrieving each element in the list at a given index, I can use the get method. Yeah. So I'll be using the get method. And here for my index, I'll be specifying my variable I, which is going from 0 all the way to the size of the list -1, because we're using or our indexing starts at 0. Okay. And just to make the output look good, I'll just add another print line here. There. Okay. Now, so we've added elements to our linked list. Now I want to print it out to see if it really added the items that I wanted to in the linked list. So if where did this come from? Okay. Let me delete that first. Okay. There. So there are no more errors in Eclipse. And if I try to run this to check, okay. So looks good, but let me improve that a bit. There. Oops. Let me improve it a bit more. Let's add commas in between the values. There. Okay. Now, if I want to change, maybe let's go from 10 to, can also go, let's say 100. So, yeah, as you can see, it was able to print out all the information there. So it's really adding the values into the linked list. So, correct. So let me just change this back from 1 to 10. Okay. So, excuse me. So we've added elements into a linked list. We've also printed out the linked list, and we've also tried to retrieving elements from a linked list using the get method. And to help you code this, I will make the paste bin. Please give me a few minutes. I have sent the paste bin, so you can go ahead and try the code that I've done. Is everyone able to access the link that I sent? Okay, so you
Yes,
can.
sir. It's working.
Okay, that's good. Okay, so you can go ahead and try that. So we're able to add and then retrieve items from a list or elements from a linked list. Now, you might think that, or maybe just like a while ago with the list, I'm not too sure if I'm really adding to the list. So let's try just adding or using the simple add here, and then let's try a different number. Let's say 1000. And there, you're able to add it. So it really does work, and your linked list is working. But I want to try the other methods. So maybe try add first. So let's change this value to 2000. Okay. So try again. So if you notice here, the value 2000 was added to the start of the list or to the first part of the list, while value 1000 was added to the end of the list. Okay, so we're able to add, which is good. Now let's try removing. So what if we try removing the first value? So let's see what happens. Okay, so it seems like it was able to remove the 2000, but I'll just copy this print list. I want to print it out after. I want to print the list after I add the values, and then so I can compare it to this print list, which is after the remove first method. And there. So you can see the linked list still has the value 2000 here at the front. And when we do remove first, it removes it from the very first, or the first element on the list. So if I want to try to do this twice, so let's see what happens. Okay. So here, we still have 2000, then it removed the first, so the first value here is 2000, and then it removed the first again, which is 1, and the resulting linked list is just from 2 to 1000. So it really is working. Now, I want to try, what if I specify, because there is this remove here where you can specify the index. So let's try at index 0. And let me just comment out these two remove methods here so that we can see what happens with this list here, the one with the 2000 and 1000. Okay. Okay. So if you notice here, so we still have the 2000 value, but when we do remove and then we specify the index 0, excuse me, it removed, or it acts just like the first, the remove first method, which is which is what it exactly does. You're removing from index 0, which is always the first index, or which will always return the first element in the list. Now, what if I want to get the second, or the third? So if you want to get the third element, you have to minus 1 to get the index, which is 2. So we have there 0. So if 2000 is at index 0, so 0, 1, 2. So it removed the value 2. Then it gave us this. Okay. Now, this is one thing I want to point out. Because if you notice, there is another method here, which is also remove, but this time it says object, so removes the first occurrence of the specified element from the list if it is present. If the list does not contain the element, it is unchanged. More formally, removes the element with the lowest index I such that object equals O, get I, if such an element exists. So what this basically is saying is that you can search the linked list for an object or a class that you pass into the method, and it will remove it if it finds it. Now, this is where it can get confusing because just like here, we're dealing with a linked list of integers, but we're giving in the index. So which one will it do? Will it remove by index or will it remove by object? Okay. So just like with this, remove 10. So let's see what happens if we try to remove 10. So which did it remove? It removed, I think, by index. So let's count by index. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Sorry. Let me just comment this out first. So just to make things clearer. Let's try it again. So here, this time it removed the value of 10. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then it seems to be removing the object 10. But what if we do this? Let's say, let's change the values that we're adding. Let's go from 10 to 20. Okay. There. So here we have the linked list. So 2010. But you notice here, after we remove 10, we're trying to remove the object 10. or the element 10, but the element 10 is still there. Now, let's see what happened. So it might have removed it by index. So let's try counting the index. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So at index 10, you have element 19. And if we look at the linked list here, the element 19 is not there. So it removed by index. Now, that's why I wanted to show this, because when you try to remove by objects and you're using values, especially integer values, it can get a bit confusing there which one you're trying to remove. But if I try this, let's see what it will do. It produced an error or an exception, what they call in Java. So it says index out of bounds exception because we're trying to access the index 1000, but our linked list is only how many items? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay. So we only have index from 0 to 12. Now we're trying to access index 1000, but what we're really trying to um, remove is the object 1000, but Java cannot seem to tell the difference. Okay, so I hope this will also maybe when you're doing some coding and you're trying to remove values from a linked list, you might run into errors like this. Hopefully this will explain why you're getting those errors. So just a reminder, using remove, have to be a bit careful what you're trying to remove. Okay. Any questions so far? Okay, error 404, but okay already. Okay. So, okay. So if there are no questions, let's continue on. So let's try the peak, um, the peak methods. So we'll do int list as peak. So let's do just peak, and just to label my output, we'll put the method name there as a string so that we know which one we're doing. Then I'll just copy this. Then we'll have a peak first. And then for the last one, we'll try the peak class. Then we'll just label that. Okay. So let's go ahead and run this. Okay. So we have our linked list, but of course, wait, let me just comment this out first, the remove to, so that it will just be clearer. Okay, so that's our linked list, 2010, 11, 12, 13. So if we peak, using the peak method, it returned the value 2000. Okay, so that's what the Java API says. It will retrieve the first element in the list and then return that. And for the peak first, so it does the same. And the peak last, it gives us the last value, which is your 1000 here. Okay, so very simple methods. Okay, Now, just a reminder also, the methods that I've shown in this demo and also on the slides, these are just a small portion of what you can find on the Java API. So it's would be nice if you could go there to when in your free time check the Java API for linked lists, stacks, and the other ADTs that I'll be showing because they give all the methods that are available that you can use for these ADTs. So now let's go ahead and sort our linked lists. Now, those of you with programming background, if you ask your students or even when you were students, they ask you how do you sort a list. So maybe you'll have to come up with your own method or algorithm to sort a linked list or maybe an array. But here in Java, well, thankfully, they provide a class that's able to sort linked lists, well, almost all types of collections. Okay. So to use that class, we'll use the collections class, the collections dot, and then it has a method that's called sort, and its input parameter is a list, and we're working with the linked list, so hopefully it will work. Okay, there. So with this, it should sort out the linked list. So let's give it a try. Okay. So this is our initial linked list. So we have 2000, 10, 11, 12, etc., all the way until 1000 here. But after we sort the linked list, this is our linked list now. And if you notice, it's in sorted order. So you have 10, 12 in ascending order. Okay. Any questions? Okay. So if there are no questions, just let me generate the paste bin link so that you have a copy of the code that you can play around with, and also you can use it with your students or your classes.
Excuse me, Sir Lee.
Yes.
Sir, may question po dito sa chat box. So, paano po pag gusto ko malaman yung nth element ng list? So, for example, fifth sa list.
Okay. So if you want to know the fifth element in the list, you can use the get method. Take note for your index, it has to be -1. So if you want the fifth element, you have to do 5 minus 1. So you have to give the index of 4. So I can demonstrate that, and I also pasted the paste bin link in the chat. So for example here, after the sorted, uh, after the sorted, after we display the sorted linked list, we can try to print out the fifth element. So we use the get method, but as like I said a while ago, if you have the fifth, since Java has or is using a zero index or zero starting index, so if you have the fifth, always -1. So 5 minus 1 is 4. So let's try. So here, this is our sorted list, and our first element here is 10, then second is 11, 12, 13, 14. So third, fourth, and then fifth. And your fifth element that we displayed is 14, which is correct. Okay. I hope that answers your question, Sir Marvin. But yeah, if you want to get the fifth, the 10th, the 100th, the 123rd, you can do that as long as it's still within the list. Of course, if you only have a list of 10 elements, you cannot get the 20th or 100th element. As long as it's within the list, and you have to just minus 1 because Java uses the 0 index as the starting. Okay. Any other questions? Okay. So since there are no questions and I provided the code for the linked list, so you can play around with that later in your free time or later on. Just try playing around with it. And reminder again, the methods that I presented here are just very small portion of the actual methods available for a lot of these ADTs that I'm presenting in these sessions. So if you're able to surf the internet, try to check the Java API. And if I'm not mistaken, the latest API is 15. So you can search Java API 15. But all of these methods have been around since Java 8, 8 and 7. But just be careful because there are some methods that might be found in the latest Java 15 or maybe the newer ones like 14, 11, 10, but they might not be found in the older Java versions, which are 7, 6. I don't know if there's still a 4, 5, but there are some older Java virtual machines still going around. So it's best to be careful when using these methods because some of them might have been removed or might have been changed. Okay. So let me just switch back to my slides. Okay. So we've declared a linked list. Now then we added, removed, seek, and then sort. Okay. So our next ADT will be taking a look at an array list. Now an array list in Java is what they call a resizable array, and it behaves similar to a linked list. So just like with the linked list and the stacks, the sets, um, you have to import the package. This time it's java.util.arraylist. And just like with the linked list, you still have to determine the collection type, and of course provide the list name. Then use the new operator followed by your array list, and of course the collection type. And again, collection type must be an object data type. So here is an array list of integers, which is just almost similar to what we did a while ago. Okay. And here are some array list operations. So you can add elements. So you can add an element, or you can add an element at a certain index. So if it's just the plain add method, adds an element to the end of the array list. You can also get the size of the array list. You can retrieve an element using the get method also. And then you have remove. So you can go by index or by object. And just like with the linked list that I was demonstrating earlier, it can get a bit tricky and confusing to use. Okay. So I'll be going to the coding demo for the array list. So let me just stop sharing first. Before I stop sharing, so we'll be declaring an array list, add elements to the array list, then retrieve an element, then remove an element from an array list, and then of course sort the array list. So can everyone see my Eclipse again? Okay. So just like with the array list, with the linked list and the sets a while ago, I'll just be using one class. Okay. So we'll declare our array list. So we'll declare an integer array list. Okay. And just like with the linked list, I'll just put in the values from 1 to 10. Okay. And then just like with the linked list, I'll be making my own method to print out the array list. And then just to make it look nice, I'll be adding some labels to my output. And just like with the linked list, I'll also start at index 0 and go all the way until the size -1 there. And then we'll also use the get method here. Right. Then we'll use commas again just to separate the values. And just to make it look nice, we'll have an empty print line there. Okay. So we were adding elements into our array list, and then we're printing it out. So let's go ahead and try. Okay. So it seems like it's working, but let's make it look a bit better. There. Okay. So it does seem to be working. Okay. So let me share this with you guys. Please give me a few moments. So there's the paste bin link. You can go ahead and try if you can access the code. Is everyone able to open the link?
Yes, sir.
Okay, so to continue, let's go ahead and try uh, adding elements or items one by one. So let's try 1100. Then we'll try running again just to see if we really are adding. And it seems to be adding. Okay. Now, there was a method there where you can add items to a certain index or elements to a certain index. So let's try, instead of 0, let's try 2. And this time, let's try 1200. Okay. Okay, so what happened here? Maybe let me copy this first so that will be clearer. There. So our initial array list was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then we added the 1100. So it added it to the end. Now we're adding 1200 to index 2, which is the third place. So 0, 1, 2, and it was able to insert it here. Okay. Now maybe you want to keep on trying. Let's try adding to the first. Let's try a very large number to see if it really works. And there. You're able to add to different parts of the array list, and you're also able to add to the end of the list. Any questions so far? Okay. So let's try removing from the list. So since we're dealing with integer values here, let's assume that Java will do it by, will remove by the index. So let's try again. So this time we're removing from index 1, which should be the second place or the second element in the list. And when we do that, so our second element on the list is 1. It was able to remove it. Okay. And if we try removing 1100, it still produces an error because Java is interpreting this as an index instead of an object. So it's trying to access index 1100, but we only have a very small array list. That's why it gives us this error, which is index out of bounds. Okay. Now, to sort an array list, it's just the same as sorting your linked list. So you can also use the collections class. And you sort and then int list. And then let's print out the array again after we sort. Okay. If we run and there. So here, this one is the array before we sorted the array. So you have the value 100,000 at the very first place. But once we it sorted it in ascending order, and it puts it in its proper place, and we have this list. Okay. Any questions so far? Okay. So if there are no questions, let me just generate the paste bin link so you can play around with this code for our array list. And there's the code, the link, sorry, the link to the code. Yes, that is a good question. So somebody asked in the chat, Sir John Ray, Sir, anong difference ng array list at linked list? I'll get into that in a bit. But any questions about the demo so far of the code?
Sir, good afternoon, sir. May I be recognized? Marvin Merlin po.
Yes, Sir Marvin.
Di ba sabi na may tinatry tayo kaninang, let's say, remove, di ba yung 100,000 po ba yun kanina?
Yes.
Let's say, for ganito na lang po para mas mabilis po. Let's say, I want to, let's say, remove yung lahat ng mga, let's say, number 8. Hindi yung 8 element po, kunya number 8.
Yes.
So, paano po kaya yun? May shortcut po or parang isa-isahin ko na malaman yung
for that, especially when you're dealing with integer values, I think the quickest way to solve that is isa-isahin mo. So you have to start from the first element, tapos check mo yung value
ng index po niya.
Oo, tapos actually, sige. I think I can demo that pretty quick. Sige.
Sige po. Anyway, nakuha ko po yung idea. Thank you po.
Okay. They can do remove elements. Then we just put in the value. Yung parameters dito I'll be passing the integer list or the array list, and yung target dito is the element that we want to remove. So yeah, the quickest way to do that would be to use a for loop, and then go through the list one by one, and then check if if the element at the index, is equal to what you're looking for. And if it is, so if it's true, if this condition is true, then we just do the in-list that remove, and then you specify the index, which is given by I. And then this will go on until it removes all the values given by your target. Okay. So maybe let me modify my code a bit. I'll comment this out. Okay. So let me just check. Okay. So there are multiple values of 1 here. Now, if I test my remove element method, so this time I'm looking for 1. So let's try printing the array there. Okay. So it seems to do partially what we're asking for. may hindi lang na kuha na isa. Okay? And I can generate the code for this on Pastebin, so you can try playing around with this. Try to see saan ako nagka-error, because if I take too much time trying to find out the error here, baka maubusan na tayo ng oras. Okay? So partially it does what it's doing or what we want it to do. It's removing yung multiple or these two values of one, but may naiwan pang isa, so there might be a flaw somewhere in my code or in my logic. So maybe you can take a look at this. Okay. But the concept is the same as I explained to Sir Marvin. Maybe Sir Marvin, you can play around with this, and baka hindi lang akong may nakalimutan lang ako or may hindi akong naisip kaya naiiwan pa yung one doon. Okay? And here is the code for that. Okay. Any other questions before we continue? Okay. So if there are no more questions, I'll go back to my slides and then I will answer Sir John Ray's question. Ano ang difference ng array list at linked list? So let's continue with our slides. So Sir John Ray was asking, so what's the difference between linked list and array list? They're very similar but have some key differences talaga. The linked list is faster when adding or removing elements but slower when using the get method. And this is because it has to search for that, or it has to start from the very start of the linked list and go to that index of what you want to get. Okay? So that's why medyo mabagal. Yung array list, it's like an array, but it's resizable. So yung get method dun is just like accessing from a regular array, which is mas mabilis. And both have some similar methods, but linked lists have a bit more methods available. You can check this on the API, but halos magkaparehas talaga sila. Linked lists might use more memory than array lists, and array lists are not too flexible when converting to different types of collections or data structures. And speaking from experience, I also had some trouble converting, say, array lists to linked lists or linked lists to stacks or to queues. Pansin ko lang mas flexible yung linked list. You can easily convert it into a stack, into a queue, or into an array list, or maybe into a set also, pwede rin. And there are some that advise to use an array list when your program retrieves data randomly. So for example, you're not getting elements sequentially, like from the start until the end. Maybe you want to get from the middle first, and then from the last, and then somewhere in the first. So if you use linked lists, baka medyo mabagal. Mas mabilis daw kung array lists. And use linked lists when your program does more adding and removing data. So this is just some advice from people. From personal experience, making programs in Java, dealing with large records, I don't really see too much of a difference between an array list or a linked list. But I tend to use linked lists more kasi parang mas flexible para sa akin. But this is just a personal preference lang. Now, yeah, just some things to consider din. Just like kanina, Maga, when I mentioned na if you use arrays or linked lists or pointers when making your program, maybe if you're developing a program for or an app on Android, you might want to use an array list instead of a linked list. Kasi with cellphones, even though may mga cellphones ngayon na medyo malaki-laki yung memory, baka it might be better to use an array list to medyo bawasan siguro yung memory. So I hope that answers your question, Sir John Ray. Very similar talaga sila and they behave similarly, but which one's better than the other, that's still up that's still a debate. Personally, I don't see too much of a difference. It will make a difference on the program that you're trying to make. Okay. Any other questions about array lists? Okay. So if there are no questions about array lists, yeah, just a reminder again, it really is very similar to linked lists. Kaya sinama ko rin dito just to show that medyo very flexible talaga si Java. There's a lot of implementation and a lot of built-in packages, AGTs that you can use. The problem lang there is which one do you use? Well, that will depend now on your problem or your preference. Okay. So let's continue with our coding demo. So coding demo part 2. Next, we have stacks in Java. So recall, a stack elements can be added and removed only from at the top. And just like with the ADTs we've been looking at, kailangan mag-import lang. So import the java.util.stack. And then, pansin nyo, halos parehas din sa set, sa linked list, sa array list. So parehas lang. Use the reserved word stack and then yung collection type. Kailangan object data type pa rin. Okay. And then, you have to declare a new stack. Yan. And then here's an example. And ida-demo ko din mamaya. Then you have stack operations. Now, pansin nyo, yeah, since yung stack na ito, you can think of yung stack and also later queues as sort of specialized linked lists or pwede ring specialized array lists. Medyo limited or medyo konti yung operations that you can do on it. So just like this, you have yung push, so add an element to the stack, or yung pop, remove an element, but you can also pick, so returns but does not remove the element at the top of the stack. And you can also check for an empty stack, so returns the Boolean value true if the stack is empty, false if otherwise. So let's go to our coding demo for the stack. So we'll be declaring a stack, and we'll be adding an element to a stack and then removing an element from a stack. So please bear with me for a few moments while I set up my Eclipse. Can everyone see my Eclipse?
Yes, sir.
Okay.
Nakita na po.
Okay. Okay. So, same with the other demos, isang class lang ang gagamitin ko. Okay. So, next we'll declare a stack.
Ay, hindi po siya marunong magdandi. Lalaki po talaga ata pong anak ko eh.
And let's import the stack package. Okay. And just like the previous examples, we'll be adding lang the items from or values from 1 to 10. So, okay. Now notice, yeah, you have some methods there, but you have to use the push method when you're dealing with stack. Okay. And for this one, I'll be doing something a bit different to show the stack or to display the stack. Okay. So what I'll be doing, so I'll be pushing items into the stack, and then when I'll print out my stack, I'll be popping or taking or removing elements from the stack. But notice that I didn't make a method kasi well, we're manipulating the stack already. So, kasi kapag ipa-pop out ko lahat, magiging empty na yung stack natin. Okay? So, I'll use the while loop. So, while my stack is not empty, then I will print out yung laman ng stack ko. Then we'll just add a comma to remove, put, or just to separate the values. Okay. Okay. So let's go ahead and run this. And so this is our stack 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And pansin nyo, it's the reverse order of what we put in the stack. Kasi when we're putting values into the stack using the for loop here, so we went from values from 1 to 10. So since yung stack ay LIFO, last in, first out, so dapat yung nauna ay last na lalabas, which is tama naman yung pinapakita dito ng, or while we're popping out elements from the stack. So yung nasa taas ay yung last na pumasok, which is yung value na 10. And then, so we keep on popping out or removing values until empty na yung stack, and then mag-e-end na siya. Okay? Yeah. Now, you might wonder, what will happen if I pop out of an empty stack? So if I try this, inapi ko lang ito dito. Let's try running this. Nagka-error siya. So the error that it gave is empty stack exception, which is tama naman. You're trying to remove an element from an empty stack, or parang kung may bottle of water ka, you're trying to get water pero wala nang tubig doon sa bote. Okay? So let me just comment this out. And let's try the peak method. So system. So yung peak method, it will just return the value, yung top pinaka-top value ng stack, but it won't remove it. Okay? So let's go ahead and run this. And yan. So pansin nyo, peak, return niya yung very top value or yung value na nasa taas, which is 10. Tama naman. But pansin nyo when we're removing items from the stack using the while loop here, pansin nyo, andyan pa yung 10, which is tama naman. Okay? But what if, try ko palitan, let's try this one naman. Paano kung pop naman siya and hindi peak? Let's see the difference. Okay? So, kapag pop, tatanggalin niya talaga. Kapag peak, titignan lang niya yung value, tapos ibibigay niya. Okay? But hindi niya tatanggalin yung value na yun. Okay? And mapapansin niyo talaga, this is like a specialized version or a refined version, maybe, of a linked list and maybe also of an array list. Okay. Are there any questions? I will just generate the paste bin link for the code. Are there any questions about the stack that we implemented? And yeah, there's really not a lot of methods available for the stack kasi very specialized linked list, or let's call it na lang a collection. Very specialized collection to. So you can only push objects in or pop objects out and check yung top or check kung empty yung stack niya. Okay? Any question? I think we can end muna for now, this second session. Elkie, okay lang kung medyo maaga tayo mag-end?
Yes sir, okay lang naman po.
Okay. Unless there's
Kung-
any questions
kung may
from the
questions.
audience. Oo.
Ako na lang sir magtatanong. Para, opo. Siguro sir, since simple lang yung mga examples po, so kung in-extend po kaya natin, ano pong real world na applications? Opo, kahit simple na project lang sir, para lang makita yung importance ng data structures and algorithms sa programming.
Well,
ayan po.
Dito sa stack, yung medyo binibigay na problem and very well-known problem, yung balanced parentheses. So, how do you know, halimbawa sa equation, kung balance ba yung left and right parentheses nyo? Yeah. So, you can read in a string. Usually, stack ang ginagamit dyan. Kasi the stack can keep track of how many left parentheses there are. And then, mabibilang din niya or mamamatch din niya dun sa right parenthesis. So the general algorithm there is whenever you see or whenever your program sees left parenthesis, ipupush niya into the stack. So if you keep on doing that, kung may nakita siyang right parenthesis, magpa-pop siya from the stack. It will keep on doing that until it reaches the end of the string. Kung may laman pa yung stack, well, hindi balanced yung string or hindi balanced yung parenthesis. Kung nag-pop siya na wala namang laman in the string or walang laman in the stack, sorry, while it's still processing the string, hindi na balanced yung parenthesis nyo. That's one application for yung stack. Another is to, I don't know if some of you are familiar with the reverse Polish notation, if I remember it correctly, or the postfix notation for writing equations. So everyone can still see my Eclipse, correct?
Yes, sir.
One application, I'll use this as my Blackboard. The usual way of writing equations is halimbawa ganito, 1 plus 2. But if you go for the which is called the infix notation, if you do the postfix notation, yung operator comes after the two values. So instead of 1 plus 2, magiging 1, 2, and then yung plus dyan. Okay? Now, stacks are used to convert yung infix to postfix configuration. And what's nice about this postfix notation is if you have equations na halimbawa, ng ganyan, 2 times 3 divided by 5 plus 6. So I think a lot of you have seen this either on social media, on the internet. Ano ba yung sagot dito? Ano dapat unahin dito? Yung 2 times 3 or 3 divided by 5? If you do or if you convert it into a postfix notation and then evaluate the postfix notation, makukuha nyo kung ano yung order and ano yung tamang sagot dyan. I can't recall the algorithm exactly. You can search it online, madaming examples done. And makikita nyo or mapapansin nyo how kung ano yung magiging order of operation dito. Kasi if you recall yung sa elementary, tama, the order of the operation is MDAS, so multiplication, division, addition, subtraction. Pero when it comes to multiplication and division or addition, subtraction, ano dapat unahin mo dyan? So the postfix kind of answers that question there. Okay. So that's some real world examples. Well, yung sets, you can compare lists, and which is medyo ginagawa ko din sa isang trabaho ko dito, UP Baguio. Kailangan ko i-compare yung lists, two lists, na dapat walang duplicates, and then i-compare ko kung ano yung missing, ano yung kulang dun sa lists na yun. Okay. And then linked lists, medyo obvious, and also array lists. So you can have a linked list of students or student records. Also for yung array list. I hope this gives you some idea on these data types, these advanced data types that we've been covering. And hopefully this will give you some idea, or maybe to give you some idea to how to solve some programming problems, not only in a classroom setting, pero in real life situations din. Any other questions?
Okay, thank you, sir. Sir, may isa pang tanong sa chat box. So,
Okay.
anong application mas appropriate or may advantage ang stock, ang paggamit ng stock?
Ayun. So, yung in-explain ko kanina, yung pag-balance ng parentheses or pag-check ng balance ng parentheses. And also yung postfix notation, converting infix to postfix, yun yung gamit ng stock. And well, for more advanced topics, this is how compilers operate din. They make use of yung stacks to check kung may semicolon ba, kung closed yung curly brace mo, and not only checking yung syntax pero other elements din. May tanong pa?
Para po sa mga nilalagay ng binoto, meron pa po kaya po mga tanong galing po sa audience?
Well, may tanong dito si Sir John Ray, mas mabilis po ba ang stack kesa linked list or array list when it comes to adding or removing? I cannot give a definite answer there when it comes to Java because in the concept of object-oriented programming, hindi nila masyadong pinapakita or they don't really say how they implement yung pag-push or pop. But in terms of algorithm-wise, dapat mas mabilis yung stack kesa linked list or array list kasi hindi, maybe siguro katapat niya yung linked list kasi it's only adding and deleting elements from one part of the collection sa unahan. And I don't know kung array ba to, nagshi-shift ba. That I cannot tell exactly or say exactly because I'm not sure how Java implements this. But I would say mas mabilis siguro kaysa array list pero baka siguro katapat niya yung yung linked list sa pag-add or remove ng elements. I hope that answers your question, Sir John Ray. Okay. Any other questions?
So while waiting po for others, baka may naisip pa silang tanong. So we've uploaded the link for the evaluation form sa chat box po. Thank you.
Singit din, Ma'am LK, yung top 3 na
Yes po pala.
Thank you. Please.
Isa pa lang po nag-send ng details po nila. So, Sir John Ray and Sir Niel, pasend po ng mobile number or email ad po. Thank you. So, may questions pa po ba? May habol pa po? Mukhang wala naman na po atang questions. So, thank you again, Sir Lee, for that very informative lecture on advanced data structures and Java programming. So, let's all give him a round of virtual applause. And thank you again, Sir Lee. So, maybe we can have a short photo op. So, can I request everyone to please turn on their videos. Ay, okay.
Kaya habang hinihintay na rin yung next round, ay naman.
Ay, wait. Sorry. After nito, meron pa po palang we'll have a short break, then we'll come back po after 15 minutes. If that's okay. Opo. Sorry. So anyway, let's have this short, mag-photo op na rin tayo. Okay lang. So okay lang yung iba. Day 2. And wait lang po. 1, 2, 3. Smile. Then another one. 1, 2, 3. Smile. And thank you everyone for turning on their videos. So we'll have a quick break and we'll be back after 15 minutes. Same link po, so pwedeng hindi na po mag-leave sa meeting. And thank you. So we'll be back at 2:45 p.m. Thank you. So hello everyone again. Welcome back from our short break. So let's all welcome back Sir Lee. Sorry, masyadong advance yung thank you ko kanina. So Sir Lee.
Thank you, Elkie. So I'll share my slides again. So we were doing the demo of stacks in Java. So we were able to declare a stack. Um, we were able to add elements into the stack, and we also removed elements from a stack. So the next data structure we'll be looking at is queues. So recall, similar lang siya sa supermarket checkout line, yung pila doon. And just like with the previous ADTs, we have to import the packages. This time, yung java.util.queue and java.util.linklist. So parang sa set din to. So parang blueprint lang ang queue dito. And yung pag-declare is queue, and then same din, collection type must be object data type. So yung queue name, the new linked list collection type. Okay, so here's an example there. And your operations, just like with the stack, you can think of it as like a specialized linked list or maybe array list. So you can only add, remove, and pick. And pwede rin yung i-check kung empty yung queue nyo. Okay? So for our coding demo, medyo iba yung gagawin ko. Kinode ko na kanina during the break, and I can show it to you, and then don't worry, I'll provide you with the code din through Pastebin. So let me stop share muna. Can everyone see my Eclipse? Okay. So kinode ko na yung demo. So don't worry, I'll be sending this out through Pastebin. So eto, yung pag-declare, parehas lang, almost parehas sa stacks and sa linked list, pero mas kahawig niya yung set. So queue, integer, yung int queue, linked list, yeah. Okay. Then, dito yung ginawa ko, print out ko, pero I'm removing from the queue. So natatanggal yung laman ng queue. Okay. So if we run this, yeah. So, simple lang. Yung add, of course, tinalagay niya sa dulo ng queue. And of course, hindi pwede sa unahan or anywhere in the middle kasi bawal sumingit sa pila. Tama? So, ayan. So, very simple lang talaga yung queue. It's just like yung stack. Very specialized siya talaga. So, I will provide the code for the queue so you can play around with it on your free time. Okay. There. So that's the code for the queue. So you can try playing around with it, modifying it on how you want to use it. Okay. So let me go back to my slides here. Now, the next data structure that I'd like to present, and this is the last one na, pero medyo mahaba, will be yung tree. So we looked at the tree kanina, yung concept niya, but unfortunately, there's no built-in Java packages for trees na yung traditional or yung concept talaga of the tree. Okay, so this time I'll be implementing my own tree, which will be a binary search tree, which has these three conditions. Each node has a maximum of 2 children, and the left subtrees contain values less than the node value, and the right subtrees contain values larger than the node value. So to help you visualize this, let's take a look at this image. So ito yung image or an example of a binary search tree. So pansin nyo, here is your root node 5, and pansin nyo, all the values on the left subtree are less than 5. And same goes with yung subtrees din dito. So yung 2, yung values are on the subtree of 2, values are less than 2. So 1 dyan, plus 3. Ayan. And then same din dito. Okay. So for this demo, we'll be creating a binary tree or binary search tree in Java. And then we'll add elements, we'll display the elements, we'll search for an element, and then we'll try deleting an element. So just give me a few moments while I set up my Eclipse. Can everyone see my Eclipse again? Okay, so to start off, I will be using maybe a separate class, right? A separate class, and I'll name it tree node so that these are these will be the nodes on my tree. Now, to save on time and medyo nadayaan ko ng konti yung demo na to. Medyo may kodigo ako. I made this in advance. So, copy-paste lang muna para medyo mabilis yung demo na to kasi medyo mahaba. Ito. Okay. So, in this class, the tree node, we'll have 3 attributes dito. Yung value, which is the value that will be stored in the node. And then we have a left and right node or left and right variables or attributes, which will be the left and right nodes of the left and right children of that node. And here I just made a constructor for this node. Okay. Yeah. Now, I'll be making another class na binary tree, and this will contain, or this will be my implementation of the binary tree for Java. Okay. Yeah. Now, for the first thing that we'll do here is we'll add nodes to a binary tree. And medyo i-copy paste ko lang ito. Code ko dito. Okay. So, first part of the code here, I have a private attribute na tree node, and this will be my root. So, yung binary tree ko will have its root na gagamitin lang niya for its use lang. So, ito yung root ko. Okay? And then, I'll have a private method dito na add node recursive. So I'll be using recursion to add nodes to my binary tree. So yung parameters that I'll be passing is the current node or kung anong node man to, kasi recursive function to, meaning it will keep on calling itself, and what value I want to store in the binary tree. Okay? So, yung base case ko dito is if your current node is null, meaning walang laman pa, or it's at the end of your, or nasa leaf or leaf to, ng binary tree mo. So, all we have to do is just create your new node and yun ang i-return ng function na to. Okay? Now, if your value is, kung may binary tree na kayo, so if your value is less than yung value ng current node, so dapat nasa left subtree siya. So, that's why ina-assign natin dito to the left subtree, and we're calling the recursive function again para siya na mag-create ng node doon. And then, next, yeah, so of course, if your value is larger than what's the current node or the value of the current node, halimbawa kanina yung 5, tapos you want to add 7, so dapat nasa right subtree siya. So, we'll assign the current node to that, and then we'll call the recursive function again. Then, pass natin yung value. Or else, if you're trying to add 5, we're trying to make it unique sana yung mga values dito. So, ipiprint out lang na value is already in the tree. So, wala siyang gagawin except return the current node. And then, we'll have a public function para medyo or easier to use for other programmers. And it will only, yung gagawin niya is, i-add lang niya yung node, or it will take in the value that we want to add to our binary tree, and then we'll do the recursive add to the root. Okay, so this recursive add node recursive is private, so hidden siya. We don't want the programmers or any other people to see this or access this. They'll access or they'll use this public method, yung add node, para to add the values dito. Now, I'll create another class with yung public static void main. Ito yung parang test class ko. Yan. Okay. So, what I'll do now is I'll instantiate my binary tree. Yeah. Then I'll add some values. Add node 5, let's say. Let's say 7. Then let's say 2. Okay. Yeah. Now, ano lang ako, I want to try and see kung if it's creating my tree. But how do I do this? So I have to provide a way to print out the binary tree. So I'll go here muna to my binary tree class. And then we'll be using what they call yung breadth first search or breadth first traversal of a binary tree or of a tree in general. Okay. So let me just copy the code. Yeah. Now I have here the breadth first traversal. So if wala namang laman yung binary tree nyo, it won't do anything kasi you can't print out kung anong wala dyan. Okay? And then, The general algorithm is, so gagawa ka ng queue. So just add the current nodes there in that queue. Then while hindi empty, so remove, and then ipiprint out lang natin yung current node, yung value niya. And then check if you're left, kung may left child siya, kung meron, then print out natin. And then we add this node to the queue. And then, i-check din natin kung may right child siya. Kung meron, we print out the value. And then we add the node to the queue. And then, while the nodes or the queue is not empty, then just keep on doing this until we traverse the whole tree. Okay. So we have this method now. So let's try printing out our binary tree. Use this first traversal. Okay. And let's try. Okay. So, of course, medyo limited tayo sa pag-display ng tree using yung console. Kaya medyo inano ko na ganito. So your root node is 5. Tama? That's the very first value that we inserted or we added to our tree. Then to its left is yung value na 2, which is tama naman, part of the binary search tree. And then to the right is yung value na 7. And then, since we're at the root node, so we go to the next level. So the current node is 2. And yung current node. And since wala siyang children, so wala siyang gagawin. And then, go on to the next one. So 7 siya. So you have yung nyo na 5, 2, and 7. Okay. So it seems to be working. So what if we try adding more values? Let's try 1. And let's see 3. Let's try 6. And then let's try 8. Okay. So let's go ahead and run this. Let's see what happens. Oops, what happened there? Yeah. So our root node is still 5. On the left side, it's 2. And then, or yung child niya sa left is 2. On the right, it's 7. Okay. Then for yung node na 2, may anak siya sa left na 1. Then may anak din siya on the right na 3. Then for the node 7, okay. So you have 7 and then 6 on the left and then 8 on the right. And then of course, yung 1, 3, 6, and 8, wala na silang children or leaf nodes na sila. So, okay lang na ganyan siya. Okay. So, it seems to be working naman. So we're adding elements to the binary tree. Now, let me just check my slides again. So we're created a binary tree. We're adding an element. We've added elements to the binary tree. Then we're displaying the elements in the binary search tree, which we've done. Now let's search for an element in the binary search tree. So let me just go to the binary tree class and let me just copy the methods for searching. Okay. So I added 2 more methods here sa binary tree ko. First is a private method that returns a Boolean value na depth first search. So gagawin niya, starting from the root, it will go down per depth or per child. And then hahanapin niya yung search value natin. Okay? So, if current node is null, then return false, meaning hindi niya nahanap. If target is equal to current node that value, meaning nahanap niya, so i-return niya true. But if it's not, if you're looking at the current node value, tapos yung target or yung hinahanap mong value is less than that value, then of course, go to the left, um, left, left node. Kung hindi, dapat sa right, and medyo error dito, dapat. So, just continue doing that, and this is a recursive function, so hahanapin at hahanapin niya basta andun within the tree. Okay? And since this is a binary search tree, yeah, basta if the search value is less than yung current value ng node, dapat nasa left side. Kung greater than, dapat nasa right side siya. And then, so this one, this is a private method, so hindi makikita yan mga programmers or anyone else. So I'll be providing a public method na search value. And dito ipapasok ng programmer or user yung value na gusto niyang hanapin. And then there, if depth first search, so hahanapin niya. And kung mahanap niya, it will just display a message na element in binary tree or element not in binary tree. Okay. So let's check and see if this works. So we'll use the same tree, and then we'll print it out again, and then we'll try searching for a value, search value, and then let's try the leaf nodes. Let's try 6. Okay. So let's run. Okay. So nahanap naman niya element in the binary tree, pero what if my algorithm is wrong? So let's try something that's not in the binary search tree. Ayan. So when we tried searching for 10, wala. But if we try any of the values that we've added, let's say 1. So element is not in binary search tree, element in binary tree. Let me edit this a bit para medyo user-friendly naman yung pag-display dito. So let's try it again. Okay. So element 10, so i-display niya yung value what we're looking for. So it's not in the binary tree, element 1 in binary tree. Okay. Any questions so far? Okay. So clear pa? And don't worry, I'll be providing all the code here, pero mamaya after i-present ko para isang bagsakan na. So let's continue. So we're able to create a binary search tree, add an element to the binary search tree, display the binary search tree, search for an element in the binary search tree, and then we will delete an element from a binary search tree naman. Okay. So let me go back to my binary search tree class, and then let me just copy my code here. Okay, so I added 3 methods here. The first one, it's a private, private method. So this will be the one to delete or to delete a value or remove a value from the binary tree. So dito, yan. The first case dito or first base case ng recursive function nito is of course, kung empty yung tree mo, dapat hindi siya magde-delete from the tree. So, i-return lang niya yung not. Now, if it will keep on looking, or, okay, sige, let's start here first with the first if, ano dito. So, if yung value or yung gusto mong tanggalin na value is nahanap niya sa current node na yun, there are uh, three possible scenarios, cases that will happen. But the first is na leaf node siya or wala siyang children. So, gagawin lang niya, i-delete lang niya yung node na yon. Yung problema lang is if may anak siya, well, kung meron sa right side, or sa left side, sorry, dito, the next if statement dito, if the node has a left child but no right child, then all it has to do is parang ililipat niya yung child doon sa kung saan siya madidelete. And the same din dito, kung may right child siya pero walang left child, pero kailangan mo i-delete yung root node, let's say it's the root. So tanggalit lang yung root, tapos kailangan i-akyat lang niya yung child para maging parent na siya dun. Now, the next case is medyo mahirap. Paano kung may left and right child siya? Okay? So this is where it gets a bit complicated or a bit difficult. Now, there's two ways of deleting a node that has a left and right child. So the first one is you look for the maximum value or the highest value on the left subtree, tapos yun yung magpapalit sa node mo. Or you can search the right subtree for the smallest value para yun yung papalit doon sa didelete mong node. Now, why are we doing this? We have to do this para our binary search tree still has the property na all the values on the left subtree must be less than the current value or the current node value, and also with the right subtree, kailangan all the values on the right subtree must be higher than the current value. Okay, so I used another method na find smallest para hahanapin lang yung smallest value either sa right or sa left. Okay? And i-delete niya yung value na yun. Okay? So, ito yung find smallest value. And for this implementation, what I did was I was looking for the smallest value on the smallest value on the right subtree. So, pinili ko yung paghanap ng smallest value on the right subtree instead of yung looking for the largest value on the left subtree. So, once it finds the smallest value, papalitan niya and then i-delete lang niya yung node na yun. Okay. And I provided a public method na delete node, and yun yung magdi-delete, or the programmer or user will be using this method to delete values from the binary tree. So let's check and see if this will work. So let's try deleting the root node and let's see what happens. Okay, so let me just adjust. Let me expand there. Okay, so this is our tree that we've added to So this is the tree that we created. So yung root node ay 5, 2, then the yung children niya ay 2 and 7. Okay? And of course, yung ano dito. Now, after deleting, let me modify this code just to put a label na we're deleting from the tree para lang makita natin dito sa output natin where we're at what part of the program we're at. So, yan, deleting from tree. So, we're deleting yung root node na 5. So, dapat yung value na 6, tama? Which is kung anong lumabas dito ay pumunta doon sa ano ng 5, tama naman. So, look at the left node, it's still less than yung 6. Your right node is still greater than 6. So, it's still a binary search tree. Then, the current node 2, sa node na 2, 1 and 3, okay pa dyan. Current node, kapag sa 7 naman, pansin nyo, nawala yung 6 dyan. So, let's check. Yeah. Dito sa 7, you have 6 and 8. Pero dito, after we deleted yung root node na 5, so, yung 6 umakyat sa root, yung 7 naman, nawala yung left child niya, and then, yung 8 na lang ang naiwan. And then, yung leaves na lang ay 1, 3, and 8. Kanina ay 1, 3, and 6. Okay? So, we can try deleting other values from here. Let's try 2. So, let's see. So, 5, 2, 7. That's the original. So, dito, 5. Natanggal yung 2. So, umakyat siya. Naging 3 na dito. So, 3. And then, left node is still 1. Tama naman. Ayan. Okay. And, let's try. Paano kung 8? Ito yung leaf node. So, 5, 2, 7. 2, 7. 1, 3, 7. Nawala yung right child ni 7. So, naiwan na lang si 6. And yung leaves nyo ay 1, 3, and 6. Okay? Ayan. So, there now, by implementing our own version or our own code for a binary search tree, we now have a tree ADT that we can use with any of our programs. Now, you might ask, anong application ng binary search tree na to? Well, as the name implies, it's a search tree, so it's nice or it's good to use when you're trying to store values that you like to search often. So, pwedeng numbers, pwedeng names, ano pa, values, names, or almost anything that you want to search through. Kasi mas mabilis yung pag-search using a binary search tree instead of using yung traditional searches like the brute force method is starting from the very first element and then going to the last element. Okay? And then here, you can find the smallest value easily by you keep on going to the left subchild, makikita nyo or makukuha nyo yung minimum value, and you can also get the maximum value if you keep on going to the right subtree and kunin nyo yung pinakamalaking value doon. Okay? Yeah. Any questions from the audience? And siguro just give me a few moments to share this on Pastebin. Sorry. Sorry, but I cannot share anymore on Pastebin kasi I reached the limit pala. May limit pala ang Pastebin. Maybe I can talk with the SINSM Secretariat so that they can provide you a copy of the codes here, of this code, because you can use this one not only on yung mga sa classroom, pwede rin for any application that you might want to use. And yeah, it's very good for keeping data that you search through a lot. Okay? So I'll coordinate with the SINSM Secretariat to so that they can provide you a copy with my code, because I cannot share anymore on Pastebin. Any questions? Okay. And thank you very much for listening. Kung may pahabol pa kayong tanong, pwede pa. And yeah, that actually ends this series of lectures from me about advanced data structures in Java.
Okay, once again, thank you, Sir Lee. So let's give him a round of virtual applause. So are there any questions po?
Thank you once again for bearing with me. And medyo mahaba, medyo madugo din kung minsan yung lecture na to. Pero hopefully you're able to gain some ideas about programming, and sana madala din nyo for your classes. And yeah, don't worry, I'll provide the code din for yung last code, yung binary tree, na medyo helpful siya. Thank you very much, and thank you.
Okay, thank you din, Sir Lee. So again, thank you rin everyone for listening, no? So just a few reminders po. So yung mga gusto daw po mag-member sa MSP, we have a deadline. So hanggang May 15 po yung deadline for the membership. Ayan, so may concerns pa po ba or questions? So kung wala na po ay, yes po.
Baka merong hindi pa nag-evaluate.
Yes po. So i-share ko po tong screen ko din. So ito po yung QR code. So you can just scan the QR code flashed here for easier access po nung evaluation form for Sir Lee. Ayan po. So, kung wala na pong tanong, thank you po ulit, and see you again po tomorrow at 10 a.m. in the morning for Dr. Joel Adawi's lecture on Basic Agent-Based Modeling. So, kung tapos na po mag-evaluate, may announcements pa po ba? Ayan po. So, yes po.
None na from me.
Okay, kung wala na po, so ipa-flash lang po namin tong QR code. Siguro until 3:45 po. So i-end na po namin yung meeting. So kung tapos na po, ma-scan, ma-picturean or ma-answeran po yung evaluation form, pwede na po tayo mag-leave. And see you po tomorrow at 10 a.m. Thank you. Na-send na po ulit dito po pala sa chat box yung link po for the evaluation form, yung po hindi makascan ng QR code.